Good day, greatens. I want to do this question. I'm just going to make a quick video. This is question 4, which was based on the June exam that you wrote, I think, last week. So this is the hyperbolic question. Question 4.3 says, the sketch below are the graphs of the functions defined by h of x, which is p over x plus q, where x is not equal to 0, and kx, which is equals to minus 2x minus 4. So let me show you the graph. These are the two graphs. The other one is h of x, the other one is k of x. So let me just write these two formulas, equations. So they said that the first graph, which is the hyperbolic graph, it has this equation, which is h of x. Let me make this smaller. So it has this. Okay, so these are the two equations for these two graphs. So the hyperbolic graph has the equation h of x is p over x plus q. Then the straight line graph is k of x is negative 2x minus 4. So let's read the statements. The dotted line passing through y is equals to negative 1 is the asymptote of h. Okay, let's look at it. Yeah, so this is the asymptote of h. There's a line that is passing through. There's a line that is passing through the y-axis. So this line, they said, is an asymptote. That means that this is going to be our q. So q is equals to negative 1. That means this graph has been lowered 1 unit from the point of origin. It has been lowered to negative 1. So we already know what is q. Remember, q is the value if the graph has been lifted up or the graph has been shifted down. So we already know it is shifted 1 unit down. Then they said again, the graph cut each other at point A, their x-intercept and their x-intercept and at C. Okay, so at point A, they cut each other. Let's look at point A. Yeah, point A and point C. They cut each other at point A and point C. So this is point A. They cut each other at this point. At point A, we don't know what are the coordinates of A. We don't know the x and the y coordinate of A. And they cut each other again at point C. We do know the x coordinate of C is half. We don't know the y coordinate. They just said m. So that's the information they gave us. Again, lastly, they said B is a point where the graph of G cuts the asymptote of H. Okay, let's look at that one. B is a point. B is a point where the graph of G cuts the H asymptote. Okay, here is B, so it cuts the asymptotes. Okay, we can see that the B, remember this dotted line was the asymptote of h of x. So B is cutting that asymptote now at that point. Okay, that's what they told us. Yeah, the y-intercept of h is at y is equals to negative 4. Yeah, so we see that one, the y-intercept of h. This is the y-intercept of this straight line. It cuts the y-axis at negative 4. Okay, now let's go to the question and see what they required us to do. So 4.3.1, they said write down the value of q in k of x. Write down the value of q in k of x. So we have written the value of q. We said q is the horizontal asymptote. It cuts the y-axis at negative 1. So we have already answered that one, that q is equals to negative 1 is the asymptote of the hyperbolic graph. 4.2.3. 4.2.3, let me increase the font. 4.2.3, determine the coordinates of A in K of X. Determine the coordinates of A in K of X. So let's look at A. So that is the point A. So we are looking now for the coordinates of A. Remember, A is a point where the straight line intersects with the hyperbolic graph. So we can use now the straight line, because we do have the straight line equation, which is this one. K of x is equals to negative 2x minus 4. We cannot use anything on the hyperbolic graph because the only thing that we know so far for the hyperbolic equation, we don't know what is p, we don't know what is x, we just know q is negative 1. So we can't do anything here. We can't find this x-intercept of the hyperbolic graph. But we can find this one of the straight line. They are intersecting at that point. So let's use this equation now to find that x-intercept of the straight line. Okay, so we're going to say here the straight line, which is k of x, is equals to negative 2x minus 4. So let's now make y equals to 0 to find x. So I'm going to make y equals to 0. I want to know what is x. So I'm going to take the 4 to the other side. It's going to be positive 4 equals to negative 2x. So I'm looking for x. So I'm going to divide by negative 2 both sides. So x is equals to negative 2x. So that means if y is 0, x is negative 2x. So that means now these are the coordinates of A. The coordinates of A is negative 2 and 0. When y is 0, x is negative 2. So let me redraw that sketch here. So remember, the straight line was looking something like this. So it was passing through. So remember, here it was passing at negative 4. So now we just discovered now the other point is negative 2 and 0. This point now is 0 and this one is 0 and negative 4. So the other point is 0 and negative 4. So these are the 2 points of the straight line. So we were required to calculate that point, which is point A on the graph. So we use the information from the straight line equation. So we know now this point A is negative 2 and 0. Then this other point is 0 and negative 4. So we just focus on the straight line because of it's the equation that was given to us. We couldn't use the hyperbolic equation. There's a lot we don't know about the hyperbolic equation. So we've discovered now the coordinates of A. It's a negative 2 and a 0. Let's do now 4.3.3. 4.3.3 says, hence or otherwise determine the value of P in H of X. Determine the value of P in H of X. Where is P? Now P is that A on our hyperbolic equation. Remember, we used to write the hyperbolic equation as I'm going to say h of x is equals to a over x plus q. That's how we used to write the hyperbolic equation. Yeah, we used to write it this way. H of x is equals to a over x plus q. But now in this question, they changed the a. Instead of writing a, they said now it is p. Otherwise, still the same thing. That a or p determines the shape of the graph. Remember, we said in the hyperbolic equation, if the graphs are in the, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. If the hyperbolic graphs are in the second and the fourth equation, then we know that a is negative. Now, if your hyperbolic equation is in the first and the fourth, we know that the a is positive. So in our case, a must be negative. So let's find now that point A. Okay, what do we know about this point? Let's go back now to our graph. So remember, the hyperbolic graph, the only points that we know about the hyperbolic graph is point A. Now this point A, we already know that point A is -2 and 0. So let's use now these known values, which is the x coordinate, this is the y coordinate. So for the hyperbolic graph, we only know point A. This is what we know. So let's use this known point A. Then we're going to substitute A and y in our equation to find this value of A. So I'm going to use point A. I can't use point C because of I don't know what is M. So let me give you a picture on the side. So we know that it's going to be negative. Now this is how the graph looks like. So this was your asymptote at -1. So our graph looks something like this. So this is what we know. It looks something like this. So for our hyperbolic graph, we only know point A. This is x coordinate and the y coordinate. So we're going to use now point A. We cannot use point C because we only know point X. We don't know point Y. So we can't use C. We have to use point A, and we're going to substitute in this equation. Remember, this h of x stands for y. So what is y in this case? It is 0. So I'm going to substitute 0 there, equals to, I'm looking for p. What is x? X is -2. What is q? Remember, q is this value. We said q is the asymptote, which is -1. So I'm going to substitute here -1. So now I'm going to take this -1 to the other side. It's going to be positive. So I have p over -2. That 1 is over 1. So I'm going to cross multiply. P times 1 is p. 1 times -2 is -2. So that means now p is -2. So we said that it has to be positive. That p is the same as the a. So my equation now looks something like this: -2 over x minus 1. So this is the equation now of the hyperbolic function. So we already know now the hyperbolic function. We substituted for the value of a. Now let's go back now and see the next question. So the next question now is saying, determine the value of m, the y coordinate of point C. Yeah, remember we said we don't know point C, that m. So they said now let us determine that m, which is the y coordinate of point C. So now we are looking for this point now. We are looking for this point, which is that y coordinate of C, which is represented by m. Okay, so to find that point, which is m, is very easy because we both now have the equation of this graph. Remember, this is the hyperbola. What is the equation of the hyperbola? We just calculated it here. This is the equation of the hyperbolic graph. What is the equation of the straight line? The equation of the straight line, they said it's -2x minus 4. So that's the equation of the straight line. So remember, point C is also on the straight line. It has that m that we are looking for. Point C is also on the hyperbola. It is the y coordinate of C, which is also on the hyperbola. I just separated these two graphs so that you can see that point C is on the straight line. It is also on the hyperbolic function. So you can look at it again on the graph. The point C, here is point C. The straight line is cutting through point C. The hyperbola is also cutting through point C. That means that you can use now any of the two equations to find point C. For example, if you use the straight line equation, point C, remember we said this is the x coordinate, this is the y coordinate. Half is the x coordinate, m is the y coordinate. So I'm going to substitute now for this. Remember, this k of x represent y. So I'm going to put a m under k of x is equals to minus 2. Now, if y is represented by m, x is half. So where I see x, I'm going to put a half minus 4. So now I have m is equal to 2 times 0,5. 2 times 0,5, that is negative 1 minus 4. That means m is equals to negative 5. So if I use the straight line, m is equals to negative 5. Now let's try to use the hyperbolic function to find m. So if we use the hyperbolic function, remember the function says h of x is equals to negative 2 over x minus 1. Remember, this h of x represents m, which is the y coordinate. So I'm going to put m under h of x is equals to minus 2 over, what is the x coordinate? It is a half. So I'm going to put 0,5 there, then minus 1. So I'm calculating m. That means m is equals to, what is negative 2 divided by a half? That is negative 4 minus 1. So that means m is also equals to minus 5. So even if you use the hyperbolic function, you're going to get m equals to minus 5. Even if you use the straight line, m is minus 5. So you can use any of the two. They will give you the same answer. So we know now what is m. M is minus 5. So let's substitute there. So we know this y coordinate is negative 5. This y coordinate is negative 5. Yeah, so now we are done with the calculation of m, which is the y coordinate. Now let's look now at the following question. So the following question now says, okay, we are done with 4.3.4. Now we're going to 4.34.5. Determine the domain of h. Determine the domain of h. In other words, the domain of the hyperbolic function. Okay, so yeah, so the domain of this hyperbolic function are all your x elements. Remember, this graph now is coming from infinity and is going through infinity. So it is passing now at negative 2, not at 0. The x elements now are all your real numbers from negative 2 going to infinity. So you just say the domain of the graph of the hyperbola are just all the x elements, which are your real numbers, starting from, coming from infinity, going through infinity. So this just write x element are the real numbers, and they are not supposed to be equal to 0. Yeah, so that is the domain, and your range, for example, will be all your y elements, which are real numbers, and your y now cannot be equal to the q. In other words, now these values, all these values that are going up to infinity and also going to negative infinity, but they must not be equal to q. Then else the graph must not cut the asymptote. The graph must not cut the asymptote. They must not be equal to q. So this is your range and this is your domain. Yeah, so that is your domain and that is your range. Okay, I think that question was just a 1-mark question. So let's look now for the, I think there are 2 more questions. Yeah, so the last 2 questions now are saying, show that the coordinates of point B is negative 3 over 2. Show that the coordinates of point B is negative 3 over 2. Where is B? Okay, here is B. So we have to show now the coordinates of this point B is negative 3 over 2. So we need to show that. Now remember, we said B is a point on the straight line, and that point is cutting the asymptote. So we have to prove now that point is negative 3 over 2. Okay, so let's go back to our graph, simplified graph. Remember, the asymptote is a point that is here, and we know the asymptote is y, or q is equal to minus 1. So B was a point that was here. It was cutting this asymptote. So we do know the straight line equation. It is k of x is equals to negative 2x minus 4. So let's use the equation of the straight line because we know it. Now we do know the y coordinate of B. The y coordinate of B is minus 1. We already know it because of it is cutting at minus 1. But they said that let's prove that the x coordinate is negative 3 over 2. So we have to prove now the x coordinate is negative 3 over 2. So we want to prove this. So we do know the y, we just don't know the x. So let's take now this y coordinate that we know, which is minus 1. So I'm going to use now this equation again. So I'm going to say my y is negative 1 equals to negative 2. I'm looking for x. So I know the y, I want the x. So we are using the same coordinates. If we want x, we have to substitute by the y. So we have negative 1. I'm going to take that 4 to the other side. It's going to be positive 4 equals to negative 2x. I'm looking for the x. Negative 1 plus 4, that's a 3, equals to negative 2x. I'm looking for x, so I have to divide by negative 2 on the other side, divide by negative 2. So my x becomes negative 3 over 2. So we have proven that the point B has the coordinate negative 3x over 2 and a negative 1. Because of we already know the y coordinate, which was negative 1. That's why we substituted it on the straight line equation. Then we went and find the x coordinate. So we are done with this question. So the last question now, the last question on our exam question was saying, okay, the second last, for which values of x is k of x not greater than 0? For which values of x is k of x not greater than 0? Let's look again. K of x is a straight line, remember. Which point on the graph is the straight line not greater than 0? So on the graph, you can see that this is 0 and this is the straight line. The straight line cuts the x-axis at negative 2. So you can see that here x is not greater than negative 2. So this is a point where x is not greater than 0. It is negative 2. So at negative 2, x is not greater than 0. In other words, we are looking at this point. This is your straight line graph. So at x equals to negative 2, the straight line graph there is the point where k of x is not greater than 0. So this is the point where k of x is not greater than 0. It is at negative 2. Okay, the last question now, for which write down the equation of f of x for which results from k of x reflected about the x-axis. Write the equation of f of x for which results from kx reflected. Okay, so we are writing here the equation of f of x which results from k of x reflected about the x-axis. So we need to write now the equation of f of x which results from k of x reflected about the x-axis. Okay, let's do this one, which is the last one. Okay, yeah. So if, for example, we remember we have the k of x which is equals to negative 2x minus 4. This is the equation of the straight line. This is the equation of the straight line graph. So let's say this was our straight line graph. Yeah, so it was looking like this. This is the straight line. It has a negative gradient. You can see that here the gradient is negative. So the gradient here is negative. Now, if you want to find the reflection now of this graph, so you're gonna say now, okay, we are looking now for the graph f of x, which is a reflection of k of x. So a reflection, you just put a negative in front of that k of x. So that means that this f of x is going to be equal to negative all of this equation of k of x, which is negative 2x minus 4. So you just put a negative there. Negative times a negative, it's going to be positive 2x. Negative times negative 4, it's going to be positive 4. So that means that the graph of k of x will be 2x plus 4, which means 2x plus 4 will be, maybe the reflection will be somewhere like this. Because of now there, you can see the gradient here is positive, but the gradient for k of x was negative. So this will be the function of f of x. It's going to be the reflection of the function k of x. So now this is the equation of the function f of x, which is the reflection of k of x. Let me give you another example. If, let's say, to you find the function of k of x for that, what was it? It was h of x, the hyperbolic function. So you're going to say, what was the hyperbolic function? The hyperbolic function was negative 2 over x minus 1. Okay, my pen is a little bit slow. So this was the function of the hyperbolic function. So when they say to you find the reflection, what you have to do, you just have to put a negative in front of h of x. That means now all of this equation is going to be multiplied by a negative in front. It's going to be multiplied by a negative in front. So now the final equation of h of x will be negative times this. It's going to be 2 over x. Negative times negative 1 is going to be positive 1. This is the reflection now of the function of h of x. Now, remember, originally, our h of x was looking something like this. This was the h of x. What is the reflection now of this? If you put a negative in front, so this function now is going to look at the reflection of it around the x-axis. I think it's going to look something like this. Okay, let me draw it nicely. So it's gonna look something like this. So the reflection now is going to be the other way around. Yeah, so this would be now the f of x, the reflection of h of x. So that's how you do the reflection. You just put the negative in front of the function. Then the graph will rotate now to the other side. Yeah, so I think we are done now with our questions. I think we are done with our questions. Yeah, that was the last question. Okay, yeah, let me now go to the next video. So this was a 36 mark question for the hyperbolic function that you were writing last week. I'll see you in the next video.